everyone, good morning. I welcome you again in the world of mathematics. Here we are working on topic quadrilateral. In the topic quadrilateral, the first part we discussed yesterday, that was about curve, simple curve, complex curve and open curve. And of course, which is not curve, that also we discussed. Right now, here in this particular part of the topic, we are working on three different concepts. One is regular polygon, second is diagonals of polygon, and third is angle sum property of polygon. So let us understand first of all definition of polygon. We have seen this yesterday, it is just a sort of revision. So what is polygon? Polygon is a simple curve made up of straight lines or straight curves, right? So it's a simple idea that what polygon will give us, that is nothing but it's a closed simple curve which is made up of straight lines. So all that we can call it as polygon. So any odd shape in this manner, even if you have, we have to call it as a polygon, right? So there are n numbers of sides of polygon. It's not fixed that polygon is of these many number of sides. It's not fixed. It can be anything. But the minimum side of a polygon that can have is nothing but 3. We can have minimum possible sides of any polygon is nothing but 3, and that we call it as triangle, right? And when it comes to a polygon, a regular polygon makes a really very important role in this complete topic. So let us understand what do you mean by regular polygon. A regular polygon is that whose sides and angles both are equal. So what is equal in this case? Sides and angles. So it's a simple definition. The polygon whose sides and angles are equal called as regular polygon. Let's take example. If I take a triangle, so what will be its regular triangle in case if I say it is nothing but equilateral triangle. So equilateral triangle is called as a regular polygon whose 3 sides are equal. This is the way how we show sides are equal. And its 3 angles are equal, which is equal to 60 degrees. 60, 60, 60. And that's why we call it as regular triangle. And what is the name of a regular triangle? It is called as equilateral triangle. Side 4 if I want, then it is square. Square is considered to be regular polygon with side 4. So here we have all 4 sides equal and angle 90 degree. What if I take a rhombus? I'll tell you what rhombus is. Rhombus has got all 4 sides equal. Can I call it as a regular polygon? So you can answer this to me on the WhatsApp. Okay. So question is simple. Can a rhombus be a regular polygon? So you can answer this with complete justification. Okay. So I'm expecting this from you today. Of course, there are some other things as well, but this answer I'm expecting from you. Okay, I'm just hoping that you will send it to me. Pentagon, if I say, so here is the pentagon, which we call it as regular pentagon, and it doesn't have any specific name. It is a regular pentagon. Okay, so it has got all 4 sides equal and of course all angles equal as well. Okay, hexagon, regular hexagon, right? Hexagon can be of any shape, but regular hexagon will have the same shape which is here now on the board, right? Got the point? Hope you are clear with this. Okay, what is a regular polygon is. Fine. Let us go ahead now. The next concept is diagonal of polygon. Okay, what is diagonal of polygon? Let us just know what is diagonal of polygon. Diagonal of polygon is nothing but a join of any 2 non-adjacent vertices of polygon. अभी ये definition थोड़ा सा weird लगता है and it becomes difficult. But let me tell you, it's a simple idea. In case if I take any sort of quadrilateral, imagine in this way, let me name it as quadrilateral ABCD. If I join its non-adjacent vertices, that means adjacent vertices मतलब A and B called as adjacent, B and C called as adjacent, C and D called as adjacent, D and A called as adjacent, right? Non-adjacent मतलब क्या? A and C. So if I join A and C, it is called as a diagonal. If I join B and D, it's called as a diagonal, right? Imagine if I take a pentagon like this. I'll name it as PQRS. If I PQRST, sorry. If I join its non-adjacent vertices, that means PR I can join, PS I can join, QT I can join, TR I can join, QS I can join, and all these are considered as what? Diagonals. Similarly, hexagon. If I take a hexagon like X, Y, Z, W, O, T. Okay? So if I join all the opposite or non-adjacent vertices, we call it as diagonal. Yeah. So there are so many diagonals, isn't it? Got it. Let's go for the next one now. This is diagonal. Definition of diagonal. Is this clear to you all? Let's go for the next one. Angle sum property of polygon. This is the last concept for the first exercise. I hope you got to know. Isn't it? It has got so many different concepts in this exercise. This is the last concept. That is angle sum property of polygon. That means, as we know, if I add all angles of triangle, angle A plus angle B plus angle C is always equals to 180 degree, isn't it? Similarly, there is a specific property for quadrilaterals as well. In case if I take a quadrilateral PQRS, angle P plus angle Q plus angle R plus angle S also has got some specific value. Similarly, if I take a pentagon and if I add all these angles A, B, C, D, E, I will get a specific angle, specific value, and that's called as the angle sum property of polygon. So what is that specific value is? Let us discuss that now. Of course, triangle is a basic polygon, I can say. Basic polygon, base of every polygon I can say. Because that's the minimum polygon can be possible with side 3. Can you understand that side true polygon is impossible? It is not a polygon because it can't be a closed polygon or closed curve, right? So let us talk about quadrilateral first of all. If I join any one diagonal of a quadrilateral, then don't you think I converted this particular quadrilateral into two triangles? The angle sum of this triangle is 180 and angle sum of this triangle is again 180. So can you imagine what will be the angles of this quadrilateral sums to give? Yes, exactly. It is a 180 plus 180. Answer is 360 degree. Similarly, if I talk about pentagon and if I convert this into basic structure of triangle, how many triangles this can get converted into? It can convert into 3 triangles. So 1, 2 and 3. So what do you think the angle sum property here or angle sum will be? Isn't it? It will be 3 into 180. 3 triangles into 180. It is 540. Right? This was I think 2 into 180. Quadrilateral was 2 into 180. This was 3 into 180. Okay? So similarly, if you have n number of sides, any number of sides, now imagine number of sides like hexagon, it is 6. So in how many triangles this can get converted into? 1, 2, 3 and 4. 1, 2, 3, 4. So it is going to be 4 into 180. Right? So this is how we have the property. Can you generalize this property? Now check karo. In case if I draw the table, I'll just clear this page and I'll do it again for triangle. it is 1 into 180. For quadrilateral, it is 2 into 180. For pentagon, for side 5, it is 3 into 180, right? And for hexagon, it is 4 into 180. Okay, so this is number of side. If I say here 3, here 4, here 5, here 6, so can you generalize the rule? Can you generalize? Okay, so in case if I have n sides, so what is general rule for this? It is in fact going to be n minus 2 into 180. Whatever number of side is, minus 2 into 180 is the formula. So how to find out? Just understand it. देख लो यहाँ पे 3 साइड है, 3 minus 2 मतलब क्या होगा? 1 into 180. 4 minus 2 2 into 180. 5 minus 2 3 into 180. 6 minus 2 4 into 180. Similarly, if I have 10 sided, it's called as, I think, dodecagon, right? So in case if it is side 10, it will be 10 minus 2 into 180, the angle sum of all the angles of the polygon rather. So it is going to be 8 into 180. So now it is going to be very simple for you, for any kind of quadrilateral or any kind of polygon you have in front of you, then you can easily find out what will be the angle sum of all the interior angles of that particular polygon. And the same is true not only for convex polygon, but it also true for concave polygons, let me tell you. So any kind of concave polygon also, if you have, it is true. The same formula is true. Got it clear? Understood? Okay. Now let's talk about even diagonal. Okay. So now we'll talk about number of diagonals as well. Let us know how many diagonals each polygon can have. Okay. इसके लिए भी कोई formula है क्या? Let us discuss that. तो सबसे पहले वो previous वाला formula we will revise. तो I'll just write the formula. Formula क्या है? Angle sum of polygon is equals to, what is it? n minus 2 into 180. ठीक है? N is nothing but number of side of a polygon. Right? This is a very basic formula. You have to remember it. Fine? So in case if I want of triangle, if I want it of quadrilateral, or if I want of any of the n-sided polygon, I can easily write this formula. I can easily state this formula, right? It is n minus 2 into 180. I hope you can remember it. So now, if you have any kind of polygon like hexagon hai, या फिर maybe octagon hai, you can easily find out what will be the sum of all the angles of that particular octagon, right? The formula is n minus 2 into 180. Number of diagonals. It is also specific, okay, and इसके लिए भी एक formula है, okay. There are so many things, so don't worry, we will be revising everything properly. Don't worry for it. Number of diagonals. Can you tell me how many diagonal triangle has got? Or what is diagonal? I told you already. Diagonal is nothing but join of non-adjacent vertices. Now A and B is adjacent, B and C is adjacent, C and A is adjacent. There is no point which is non-adjacent here. That's the reason it has no diagonal, zero diagonal, right? If I talk about quadrilateral, can you tell me how many diagonal this has got? Quadrilateral एक हो गया, ये दो हो गया, two quadrilateral, two diagonals it has got. If I talk about pentagon, then 1, 2, 3, 4 and 5, right? It has got 5 diagonals. तो इसके लिए भी कोई formula है क्या? Yes, that's a very basic formula. Number of diagonal is equal to n into n minus 3 upon 2. This is the basic formula for it. Okay, let us check, let us verify it. For triangle, if I check, n is equals to कितना आता है? N is equals to 3 है, तो put the 3 value है, 3 into 3 minus 3 upon 2, कितना हो जाएगा? 3 into 0 upon 2. 0 नहीं हुआ ये, 0 into anything is 0, आ गया 0. ठीक है, चलो let's talk about diagonal of quadrilateral. तो quadrilateral के नंबर ऑफ डायगोनल कितने होंगे? फॉर्मूला तो यही है, n माइनस n इंटू एन माइनस 3 अपॉन 2. क्वाड्रिलेटरल का n कितना है, n इज इक्वल टू कितना हो जाता है, 4 हो जाता है. तो 4 इंटू 4 माइनस 3 अपॉन 2. तो 4 माइनस 3 1, 1 इंटू 4 4, 4 डिवाइड बाई 2 2. तो आंसर इज 2. राइट है ना, सिंपल. नाउ इन केस ऑफ पेंटागन, लेट अस चेक इन केस ऑफ पेंटागन. पेंटागन n इज इक्वल टू कितना है, n इज इक्वल टू है 5. तो लेट अस चेक, इज इक्वल टू 5 इंटू 5 माइनस 3 अपॉन 2. तो कितना हो जाता है, 5 माइनस 3 2, 2 2 कैंसिल. तो इट इज 5. आंसर रेडी है. राइट. हेक्सागन विच इज नॉट हियर नाउ ऑन द बोर्ड, विल चेक दैट नाउ. ठीक है, कैन वी फाइंड आउट विथ हेक्सागन और नो, लेट अस सी. तो इट इज n इंटू एन माइनस 3 अपॉन 2. राइट, इट वॉज द फॉर्मूला. n कितना है, 6 है. 6 माइनस 3 अपॉन 2 कितना हो जाता है, 6 इंटू 3 अपॉन 2. 2 1 जा 2 3 जा 6, 3 3 जा 9. 9 है आंसर. चेक करेंगे, लेट अस सी, वेरीफाई करते हैं. चलो कमन 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 कमन. हेक्सागन ड्रॉ किया. दिस इज माय हेक्सागन. राइट, हियर इज डायगोनल नंबर 1 2 3 4 5 6 7. राइट, 7. और कोई है क्या डायगोनल, देख लो. इट्स 7, जस्ट 7. सेवन नहीं है या 6 है, मुझे लगता है. कितने डायगोनल्स होते हैं हेक्सागन, कितने असतो डायगोनल. okay, it was wrongly counted. So let us see again. See, 1 2 3 4 5 6 7, and then this is 8, and this is 9. Okay, got it. It was wrongly counted, don't worry. So I hope you got it now. So two formulae we checked in this manner. One is angle sum property and second is number of diagonal. So both formulae you need to mention in your notebook. So number of diagonals is equals to n into n minus 3 upon 2, and that's it. Clear? Got it? So now it's done. आज का दिन यहीं पे खत्म हो जाता है. Now what I am expecting from you, you have to complete question number 2, question number 3, okay, 3, question number 4, question number 5, and question number 6. That's it. Your exercise is done. So I want you to complete your exercise today. Complete the exercise. Okay, I know there can be doubts. I am considering that you will have doubts, and you must have. Okay, so those doubts you can keep it pending as it is, but however is possible, whatever I taught you till this time, including your linear pair, you remember your first day part, linear pair, angle sum property, all that you have to keep in mind, all that you have to consider and start solving these questions. Okay, so which question you may face difficulty, I'll tell you. Maybe question number 3 you may face difficulty, but that's not the problem. ठीक है. In question number 6, maybe you might face difficulty in last question or second last question. Maybe 7th question only you may face difficulty, that is A and B. Baki, it's simple, it's all easy. Okay, so expecting you to try all this question. Can you do that? Really, you can do it, right? So complete it, complete this work, and maybe till 9 o'clock, exactly at 9 o'clock I'll be sending today all the solutions to you. Okay, so till then, but you have to try all this question. This is nothing but to try the questions. This time of this solution I'll be sending video instead of giving you answers. So don't worry. today I am sending you the video of answers, not just the solution of the answers. Okay, so work on it. All the questions you have to complete, get it done today itself. Okay, so see you, bye bye, see you tomorrow.